Before we get started actually prepping for assembly, I want to just talk a little bit about precision and tolerances and the individual parts. Starting with the sole. The sole is in two pieces, and you'll notice there's a tongue and groove joint. The purpose of the tongue and groove joint, is very important to realize, is not structural. It's not actually providing any strength. What it's for is alignment, and it's to ease assembly. And really the only part of this that we're particularly concerned with is what we do need when we start is a relatively high degree of coplanar between the front and the rear of the sidewall. So with that tongue and groove joint joined, you want to just be able to set this on your plate, and you don't want to have a significant gap underneath on either side. If you look on either side of that tongue and groove joint, you should not see too much lift. If you do, we need to correct it. So for instance, if we were looking at it and we had a situation where, let's say the left side of the front was significantly lifted, what we want to do is remove some material from the bottom of this tongue to allow it to sit correctly. Okay. Now anything within 0.005 of an inch or so is coplanar enough for our purposes. We're going to do lapping at the end to correct that. But it is possible that you'll need to do just a bit of adjusting to get a relatively straight surface. Okay. One of our reference surfaces for the initial assembly is this surface right here. We want that flat and straight, and so that when we insert our sidewalls, they're going to mate up quite well with this nice straight milled line is going to sit quite flush. Okay. The other section that there's a lot of play built into to ease assembly is between the dovetails in the sidewall and the pins in the sidewall and the tails in the sole. There's quite a bit of clearance. I have 3 to 0.005 of an inch clearance on either side of these pins to allow this to fit after we've done a bend, because that process of bending is going to introduce quite a bit of irregularity. And if we had tuned all these to fit, say, within 0.001 of an inch, it's not going to fit well. We'd have to do an awful lot of filing and tuning that frankly is just unnecessary. Okay, so you're going to end up with some gaps. The places you're likely to see gaps are between, if you look at the base as we progress, and this is a dry fit example model, you'll see there's a pretty good gap, really about 15 to 20 thou between the front and rear sole pieces. That is absolutely within spec and absolutely fine. It will close up quite easily in the peening process. And the order that we peen and the block that we use as a peening aid, those things are going to make it easy to close up those gaps. And this is one of the differences between this work and woodwork. You cannot strike wood with a hammer very well and expand it, right? You can only remove material, but in wood you can to some degree expand material, and that's one of the neat little bits of magic that allow us to do things like secondary dovetails. Okay, so just be aware you may see some gaps, and as we're going through I'll be sure to point out where precise fit matters and where it does not, where you may have gaps, but those are the first ones to be aware of. The tolerance that I have is for the front to the rear, you can have a gap of anywhere up to 0.020 of an inch between the shoulders on either side of that tongue and groove joint back to dead flush, right? That's the range that I've milled this to, right? Because if I had plus or minus 5, or if I had a smaller tolerance, then you would have to get the front and rear pushed together far enough for these dovetails to fit. Okay, and we want it to be an easy fit. The initial assembly should not be particularly difficult. That's not where our precision is being built in.